Hi everyone, so this is chapter 1.4 of the Pure Maths book, and this chapter is building on the previous chapter 1.3, which was when we looked at partial fractions. And in partial fractions we were taking fractions that look like this one and separating them out into two separate fractions, essentially. And we learnt two methods to do that. We learnt the substitution method, and we learnt a method called equating coefficients. But we didn't look at any questions where we had a situation like this. Now you can see in the denominator of this algebraic fraction, you have a repeated factor. So all of the questions in chapter 1.3, you would have, in your denominator, you would have distinct linear factors, i.e. just different factors. And even when we had questions like from example 9, here we have x minus 1, 2x minus 1. They are three different linear factors in the denominator. In chapter 4, though, we will look at situations where we will have repeated factors in the denominator. So this example here, in our denominator, we have x minus 5 and x plus 3 squared. Now, you can use the same method, substitution or equating coefficients, but the way we would separate this denominator out into its partial fractions would be, we would have a over x minus 5, so that's dealing with this first linear factor, and then the repeated factor, we have b over x plus 3, and then c over x plus 3 squared. That is how we would separate this algebraic fraction into three partial fractions. So example 10 is going to take us through just how to do this. So example 10, we need to show that okay, I'm going to copy out the fraction. So we have 11x squared plus 14x plus 5 all over x plus 1, 2x plus 1. To show that this fraction can be written in the form a over x plus 1 plus b over x plus 1 all squared plus c over 2x plus 1, where a, b and c are constants to be found. So they've actually given us the separation of the denominators here. So we just need to work through, and I'm going to use the substitution method because it tends to be quicker when we are doing these kind of larger problems. So what we would first do is we would pretend that with our three partial fractions that we are just going to add them, and we're going to have one common denominator. Now our common denominator, if we were to add these, would be, well, this first fraction a over x plus 1, well, to have the common denominator it needs to be multiplied by x plus 1, and it also needs to be multiplied by 2x plus 1. b, it already has a factor of x plus 1, and it already has a factor of x plus 1 squared, so b only needs to be multiplied by 2x plus 1. And then c, well, c needs to be multiplied by x plus 1 and x plus 1 again, so c would be multiplied by x plus 1 all squared, and that would mean our common denominator is 2x plus 1. There we go. So that is our common denominator, and we have multiplied each partial fraction by the factor that it needs to be multiplied by. So from this we can deduce that our two numerators are equivalent because our denominators are equivalent. So from this we can tell that x minus 2 11x squared plus 14x plus 5 is equivalent to this here. So we can make, I'm not going to rewrite that out. In fact, yes, I will. Okay, and now we're going to start to substitute in solutions to work out our unknowns. So I'm going to look at my first linear factor of x plus 1. To make that 0, I'm going to substitute in x equals negative 1. So I'm going to sub x equals negative 1. That's my first step. So when I substitute x equals negative 1 into this first expression, I'm going to get 11 times by 1, which is 11. And then I'm going to be taking away 14, which is negative 3. And then I'm going to be adding 5, which is 2. I'm going to substitute negative 1 into the right-hand side. Well, this first this whole term with a in it is going to be 0 because we have x plus 1 here, and that's a solution to x plus 1. Also, this term with c in it is going to be 0, so we're only going to have the b term. So when we substitute negative 1 into this, we'll have 2 times negative 1 is negative 2, plus 1 is negative 1. So we get negative 1b, and from this, we know that b is equal to negative 2. Then we will substitute in our next solution. So we're going to substitute in the solution to the next linear factor, so 2x plus 1. So to make this bracket 0, x has to be negative 1/2. It's 2 times negative 1/2 is negative 1, plus 1 is 0. So into the left-hand side, well, I'm going to have 11 times negative 1/2 squared, and plus 14 times negative 1/2 plus 5. So I get 3/4, or I'm just going to put 0.75. And then substituting it into the right hand side, well, this first factor has 2x plus 1 in it. This first sort of term actually has 2x plus 1 in it, so that will become 0. The next term will also become 0, and so we're left with this one. So we're going to have negative 1/2 plus 1, which is 1/2, all squared, which is 1/4. So 0.25c. Again, you can leave that as fractions if you want to, and this tells us that c equals 3. So we've got b and c, and we still need to find a, but we don't have any more linear factors to substitute in solutions for. But what we can do is we can just substitute in our solutions. So we've used the substitution method to find b and c, and we've done all that we can with this. Okay, we've done all that we can with this using the substitution method. So we're actually going to go to the other method and use equating coefficients to find our value for a. So we're actually combining the two methods that we learnt, or not combining them, but we're using both of them within one question. So we want to find a, so we're going to consider the coefficients of x squared. So we're going to consider x squared. Now if we look at the left hand side, our coefficient for x squared is 11. And then if we look at the right hand side, well, this first term is going to give me an x squared term, isn't it, when I do x multiplied by 2x. So I would get 2x squared, and that would all be times by a. So that would be 2a. Now this central term here would not give an x squared term, so that's not going to appear. And our last term would give an x squared term, and it would just be x squared by itself. So that would be multiplied by c. So we just get 1c. So these are all of the coefficients of x squared. And because we know what c is, we know that c is 3, we can actually solve this. So if c is 3, then that tells us that 8 equals 2a, because I'll take away 3 from both sides, and then I can get a equals 4. So I now have all of my constants a, b and c, and I can write out my answer. So my answer would be 4 over x plus 1 minus 2 over x plus 1 all squared plus 3 over 2x plus 1. So when you have a repeated factor, you just need to remember how to separate out the denominators, and also that you're going to use a combination of the substitution method and equating coefficients in the square term.